Mark VK3OHM, who's going to entertain us this evening on his learnings around Radiosonde. So thank you, Mark, for making the time.
All right, thank you very much. Welcome, everyone. We're going to talk a little bit about Radiosondes this evening. We're not going to get into lots and lots of detail. I've had lots of fun working out the details, and I wouldn't want to deprive you of that fun. So this is just to get you started. I had an idea for this in January, but since then there's been an awful lot of activity in the club around Radiosondes, and I suspect that some of you, and I know some of you in this room, are way ahead of me. So never mind. This is to get all of those other people who are not experts in Radiosondes to try and get them started, to at least get involved. So it's very much as at the how to get started level. I'm not going to give you all the answers. Now, balloon releases. The Bureau of Met releases 2 weather balloons a day from Melbourne Airport. And in fact, all major airports around Australia do so. In fact, all major airports around the world do so. On Wednesday, they released an additional 2 special ones for measuring ozone. And they also have a training facility at Broadmeadows, which is not far from the airport. And they sometimes release some from there as well. This slide's been a bit overtaken by events. At times I have seen 6 a day, and today we had 7 or 8. I don't know what was going on. I think it was graduation day at the training facility, and they probably had to release one in order to get their final balloon releaser certificate or something or other. But there was a real, I've got a picture of it later on, there's a real flurry of them today. I've never seen anything like it. Now if you want to get interested or get involved in weather balloons, there are 3 different ways you can get involved, 3 different levels of effort and interest. The first way is you can just watch them, completely passive. You go to a website, SondeHub.org, and you can just watch them drift by, and there's a certain level of interest in doing that. It shows the track, it shows the burst location, it shows where they land or where they're going to land. There's a prediction. They generally go east, generally around the sort of Warburton area, but they go all over the place. Some go west. So you can just watch them. I did that for a few months. You can track them. Rather than relying on the SondeHub site to do all the tracking for you, you can build your own receiver and send data to SondeHub. And you'll see your name pop up as contributing to the live traffic. I built a Raspberry Pi solution to do that. I'll show you a picture of it, but I won't go into much detail. I think there are better options now. So you can track them. You can also go and retrieve them. Yes, well you hadn't done it when I thought about this in January, but you've all gone out and got your own sondes now, so yeah, I haven't got one. So you can build a receiver, but if you're going to go out in the field and retrieve them, it's got to be a small thing. You can't lug around a laptop and a Raspberry Pi and the SDR dongle and all this other, well you can, and people did, but it's not terribly convenient to do it that way. You get a huge number of brownie points if you retrieve a Radiosonde, and Peter Freeman, VK3PF, is the king of Radiosondes. He got 6 today, so I think that's probably a record for a one day. I think there were more than 6 he could have got. It got dark or something or other. So that's what I'll call the LILYGO solution. It's a very cheap, simple device you can build yourself, and it's small enough that you can just carry it in the palm of your hand and go and retrieve. And it's the blue thing over there, which we'll look at. Not yet. We'll get to it. So you can watch, you can track, or you can retrieve. There's 3 levels of involvement. Right, so what is a radiosonde? I have one here. This is Jack's, he's very kindly lent it to me. It's got a foam polystyrene cover because it goes to very high altitude and it's very cold. And it's got a very nice electronics board inside. Now just a few details on that board. It measures temperature, plus 60 to minus 95. Gee, that's cold. It measures humidity, it measures pressure, it measures wind speed and wind direction. It's got a very nice U-Blocks GPS receiver in it so that it knows where it is. It only weighs 80 grams. That's without batteries. And it's got a 400 to 406 megahertz transmitter. It's only 60 milliwatts, but when you're 30 kilometres up, that's enough. Doesn't need much. It's got a very nice STM 32-bit microcontroller, and it's got 2 extremely nice AA lithium batteries. They're probably the most prized bit because they're very high quality and probably very expensive to buy. So if you can get to them early enough, they've still got plenty of battery life left in them. So if you go out hunting, that's what you're looking for. I'll pass that one around as well. Just if you pull it apart, be careful. It's delicate. And I don't know. There must be several thousand of these launched every day all over the world. And they're all made by one company in Norway or Finland or somewhere like that.
What are they worth?
All right, now just looking at that's the wrong picture. Anyway, that'll do. I had a picture of what it was like today. There were six balloons up all at once. Anyway, so this is from a few weeks ago. What you get is an icon, which is the balloon. It's when it's inflated, it's white, and when it bursts, it turns into a parachute symbol, so you can tell it's descending. It shows you the track, and that circle there is Melbourne Airport, and that's the Broadmeadows training facility. I guess on Zoom they can't see these laser dots. No. It also shows you a prediction of where it's going to go and where it's going to land, and that prediction's updated in real time, and it's pretty... Oh yeah, just there. That's where it's going to burst. Not particularly relevant because it's at 30 kilometres and you can't see it. Now, these green dots are receiving stations. So Melbourne's reasonably well served. That green dot there is me. And every time you receive telemetry from the balloon, you'll get a green line. And the name of the station will appear over here. The orange dots are people who have actually made a donation, so they get a bigger dot So, yeah, there's a lot happens on that screen. You can just surf over to it, and there you are. It's an interesting thing to look at what's happening. Now, there's a lot of information on these screens. The blue circle is where the horizon is. So if you're within the blue circle, you can theoretically hear it. If you're on a hill, you'll definitely hear it. If you're in a valley, maybe not. The green circle is a 5-degree horizon. So the balloon will be 5 degrees above the horizon if you're within that circle. So you should definitely be able to hear it. 401.5, but there's a couple of different frequencies. Because they launch multiple balloons at once, they all have to be on different frequencies, but they're all around 401, plus or minus a bit. I just plotted here all of the landings that occurred in January when I wrote this presentation. There were 68, so quite a few. The solid ones are ones that were recovered. And the empty ones, well, they haven't been retrieved yet. Peter will get to those eventually. And when people retrieve one, they can put a note on it saying either I couldn't get it because it was on the roof of a factory, or he didn't get it, or usually, oh yeah, I contacted the landowner and he was fascinated and we went out there in his tractor and we found it. And so you do know whether they have been found or not. So you don't have to waste your time chasing after something. Now you can see where this is sort of typical, you can see where they mostly go, out to the east. And Peter Freeman lives there. So he's all over it. So they're particularly looking for people or stations out to the east. There's a guy up here, I think it's here, there's a station up here called Big Ears, and he hears every bloody balloon. I don't know what station he's got, but he's right on top of a mountain, I reckon, with a big yagi, and nothing gets by him. Oh, I think he's got every... Yeah, he's got an ideal spot and a really good station, and he can track them all the way out. He tracks them and no one else can. And there's another station down here called Noddy, and he's almost... Is he? Oh, okay. Well, there are 2 super stations out there which can track anything, and then there's all us, the rest of them, with whatever we have. So if you live out this way, it's particularly attractive to be a tracker. Fills in a bit of a hole out there. Although the balloons are shown as white, they're not white, they're blue. Can anyone think why they would be blue? Well, don't answer then. I want someone who doesn't know. No, they land in the water and the turtles love them. So the turtles go and eat the balloon, and it's not good for a turtle to swallow a rubber balloon. So they make them blue and the turtles can't see them. Well, they probably still can, but less. So that's why they're blue. So there's a lot of interesting things to research and explore just at the SondeHub site without you doing anything. Don't even have to get out of your chair. So that's all about just watching, passively watching. You might want to get a bit more involved. So we'll talk about tracking. There are many, many ways to track these things, and I've done 2 of them. The first one, which I'm not going to talk about a lot, is you just use a Raspberry Pi and an SDR dongle. I've actually got 2 dongles, so I can track 2 balloons at once, which frequently happens. Although today it was totally overwhelmed because there were 6. I'd have to have 6 dongles, and or there's another new way which I discovered in January using this LILYGO T-beam board, which we'll cover in a little bit more detail. Wrong button. Now, just to talk about the Raspberry Pi briefly, a Raspberry Pi 4 has to be a 4 or a 3, but a 4's better. If you could get one, they're $160, and you need a dongle, that'll be another $50. I've got 2 dongles, and it's a bit difficult to go portable with such a system. It's a bit unwieldy. So it's really very much a fixed home station. Yeah, you can take it. You can take it portable. You can take anything portable, but it's not really terribly convenient. Plus, it's a little bit expensive. So, but I did that a couple of years ago now, when that was the only solution there was. So we did that. But technology's moved on. Now, this second solution, there's this thing called Meshtastic. You don't need to remember this. It's a little system that allows you to, using long-range radios, have an off-grid communication system where you can send text messages. It's got a range of roughly 100 kilometres, so you can just sprinkle these all about your farm, and you could send text messages all over the place. You don't need any phone system. It's completely decentralised. It's encrypted. It's got excellent battery life. All you can do is send and receive text messages. It has a GPS in it, and we use absolutely none of those features whatsoever. We use the GPS. It's a very nice hardware platform because it's got a processor and memory and a display and a GPS. They're designed to work at 433 megs. So we blow the software away, the Meshtastic firmware that it comes with. You just blow that away, and you put in a special sonde software. But they're cheap. The full-blown one that I've got here is, I think it's $40, and there's one without a GPS which you can use at home. It's only 20 something, 35. It's very cheap. So I just mentioned what Meshtastic is, but it's not relevant because we delete it. Now that's what a LILYGO T-beam hardware looks like. A bit later I'll pull that one apart and show you a real one. But it's got an ESP32 microcontroller unit with 4 megs of flash. It's got a transceiver. We only use the receiver bit, designed for 433 megs, but it can be coerced to work at 401 megs. It's got enough range in it. It's got a very nice GPS unit built into it. It's got the tiniest OLED display you can imagine. It's less than an inch across. So you need a magnifying glass to see it. It has both Wi-Fi and Bluetooth built in. We only use the Wi-Fi, we don't use the Bluetooth. And it's got an SMA antenna connection. And it's got a standard 18650 battery holder on the back. When you get if you get the detailed instructions from me, there are 3 different types of batteries, which are all 18650, and only one of them works. All right, we'll go there. I went to JCar and bought my 18650, and they had one which had battery protection. I thought, oh, that sounds good. I would like my battery to be protected. And in fact, on these boards, they mentioned something, oh, you shouldn't run non-protected battery. So I bought a protected battery. Didn't even come close to fitting. Too long. The protected ones are sort of 4 mils longer than the standard battery. So then I thought, oh, well, I need one with nipples on it, or a nipple for the positive. No, that won't fit either. You have to buy the one with no terminals, no nipple, no nothing. It's just completely flat on the end. It's all covered in the notes. I don't know how long the battery will last, but I think a very long time. It's weeks, I would imagine. Yeah, you just plug a USB lead into the board, and it recharges the battery. Yeah. Well, these things are designed. These things are designed to be used off grid, way out beyond the black stump. Yeah. So on the top of the board, you can see there's a very tiny OLED display. There's your SMA connector. The GPS antenna is not actually shown. It's underneath. It connects there. It's underneath the board. That's the Wi-Fi and Bluetooth antenna. Oh, there it is. Yeah, it's underneath the board, just poking out there. Well, it just floats. Well, no, it's sort of glued with a bit of chewing gum, I think, to the bottom of the board. So this is a very nice, very cheap, very capable hardware platform. Now, of course, these things look a lot better if they're in a plastic case. So, of course, there's one on Thingiverse where you can print the case. So you can get yourself a case for free. There's quite a few club members who have printers and will print you one. So that was my final hardware configuration, although other ones are possible. I just used a quarter wave ground plane. It comes with a rubber ducky antenna, and it's almost but not quite enough. With the quarter wave ground plane, you get an extra 20 dB roughly gain over the rubber duck. It's incredibly light and small. I mean, if you're out wandering around through the bush trying to find this damn thing, that's all you've got to carry. Nothing else. Yeah, it's more than that. It's telling you it's 125 metres in that direction. Now, you can do even better than that. I'll show you in a minute. You can find it with just this alone and nothing else. But there are even easier ways. So it's intended to be used for that last kilometre, where you know it's over there somewhere, but where? Well, fortunately for you, it's telling you where it is. It's constantly transmitting its position, so you know exactly where it is. It will do this for about 6 hours, I think, 6 hours after landing. So, you know, when it lands, you've got to get your skates on and get out there. Now, it uses software called rdzTTGOSonde, which you just overwrite the Meshtastic firmware with. I went through a very painful, it seemed like 3 weeks, but it can only be a week, of trying to work out how to build one of these damn things without any instructions at all. So I built up a set of instructions so other people, and since I first did this in January, about 8 people, 8 club members have built their own system. You can also run rdzSonde on your phone, on an Android phone, which has the advantage the screen's just a bit bigger and you can actually see things. There are lots of displays on that tiny little unreadable display, packed full of really useful information. Like, you know, what's the sonde ID, what's its lat, what's its long, how high is it, what speed is it doing vertically and horizontally. Wrong. I've gone too far. Right. The important one is, this is the signal strength in dBm, I think. It'll work down to about minus 100 and something, 105. And these things here, a vertical bar means I got 1 frame of good data, and a dot means I got nothing. So if you're getting a whole string of vertical bars, you're doing pretty good. So there's about 10 screens. We're not going to go through them all. There's another screen. That means it is 6 meters away and it's 109 degrees. So you can just point yourself and walk 6 meters and there it will be. So you can find the sonde with nothing except this little blue box quite easily. It is pretty incredible. Now, there is an app on the Android and it shows you a lot of information, including maps, if you have the internet. If you don't have the internet, you don't get the map. But what you can get, it shows you this. It says that little black rectangle there, that represents the phone. So that's the direction the phone's pointing. And the sonde is over here. So if you turn so that you line up the black rectangle with the red arrow and walk that direction, you don't care whether it's true or magnetic. You just follow the icon. I wouldn't be doing that in this case because it's 70 kilometres away, but you get the point that yeah, it's a bit of a walk. This is really for the last couple of kilometres, I would suggest you want to use this. Yeah, I don't have a local example, but on the Android phone, you can do everything or get all the same information you get on the screen, except it's bigger, and you actually get follow the arrow. Couldn't be simpler. And if you've got internet, you even get maps and all sorts of other wonderful stuff. But when you're that close, you don't need the map. When you're 10, 20 k's out, you might need a map. So it is useful to have the smartphone with you. It may or may not be useful to you. Now, in closing, it's probably the most fun you can have for less than $60, maybe. If you actually want to build one of these, I have a complete, I won't say it's an idiot's guide, but it's got all the essential 18 steps that it will take you to build one, and 8 people have successfully followed my instructions and I got no questions. So it must have been, it must have worked. And in fact, some people have gone on to the next level and built their own different variant. There are other variants of this board which don't have a GPS or a battery, and it's half the size, and they've built, yeah, if they don't move, you don't need a GPS. So anyway, you can build the cut down version. And I want to thank Gary Richter, 3TGR. He first mentioned the LILYGO to me in January, and he got me started. So I'm hoping to do for you what Gary did for me in January, just get me intrigued and, oh, I could build that, that's not hard. Well, it was hard, but it was fun. Questions?
Got any questions online, Luke? No, no questions online. Any questions from the floor? Tom?
I'd just like to comment and say thanks, Mark, for giving the presentation.
I think there's a role for you as president, Tom, if you're
Sorry?
if you're going to keep doing my work for me.
Do you want to do it?
Well, we might just be trying to log in via the laptop, so bear with us.
There's
One question, Mark. Have you had an interest in all the other things this device will do?
no, not in the slightest. There's very much more to this than I've shown you tonight. If I was to show you all the ins and outs of this, we'd be here next week. Yeah. It's a very diverse topic with lots of areas, but if Jack can get it working, I'll show you one. It actually has a little web server on it, so you can log in to the device.
I'm logged into this one over here at the moment, so basically these are the frequencies it's listening for, 401.5 and 402.5. Oh, talk on there. Yeah, so I was looking at 401.5 and 402.5. And I won't go to the Wi-Fi because I might give too much information away, but we can go to a live map. The live map will come up and it'll have the last time it heard a signal, which was a few weeks ago. Yeah, it's looking at the moment. It's looking at the moment with the wrong date and all that sort of stuff. It's and those orange ones mean that it's not hearing anything at the moment. And down here is a little dot down the bottom here. You can see the mouse up here. Yeah, that's my current location. You can zoom in on that map. You can zoom right in on that map. And so used to using the mouse, I suppose. So we can go in. And it should come up in Burwood. Oh no, it's showing me in Vermont. So it's I'm not seeing a GPS fix inside here, I don't think. That's probably why it's showing me in Vermont at the moment. Now we can go across, we can get out of that screen and we can go, these are just the normal screens you would use, into the map screen, which is the normal way you would log in if you're logging in on the web and looking at the SondeHub tracker. So we'll kill the text screen over there. It's saying no location, but it's working out where everything is at the moment. Should come up with it hasn't got the GPS reference there. It'll have a GPS there and we can log in and it'll just click on that and it'll go to Australia, but we just go. Oh, you can see this is Europe. There you go. These are all the sondes that have been found. These chase cars are all over the place. We'll see.
I'll just explain that. That's an interesting point.
Get down the map a bit. There we go.
Use this one. You would normally have this located at home and you tell it your position. And when you move more than a certain distance from your home, it says, oh, you're in chase mode. So you will appear on SondeHub as a little car with the word chase underneath it. So we can see who's chasing. And if it's Peter, you go, oh, no point, we won't bother.
Most common recovered around those permission. These are the ones that recovered, so it's details there.
You also want us to come up on the map chasing the mobile phone and go to our website and do it that way.
Yeah, there are many different ways of doing the same thing.
Now, any one of these stations that you see on the map, you can click on one and it'll come up TMC.
Oh.
You can put some information about yourself, Diamond.
Click on that. Click on that one.
Yeah.
No, the one above it. That's the best one.
OHM,
Yeah.
70 centimetres vertical. And then, triple W. I'm using a folded dipole on a little preamp
Yeah.
on my one.
Yeah.
Yeah, sorry, I need two mics. But yeah, that's the sort of stuff too. And then the control stuff, this is all where you go and set everything up. And you can set up your home lat and long. You can set up your, or in config I should say, in the config file, all this stuff here.
There's a gazillion parameters in the config. Don't touch any of them except your position.
Yeah, your fixed latitude and longitude, that
You
sort of thing.
specify what
there.
your latitude, longitude is.
You can put your call sign in or whatever
Yeah.
else you want to put in there. Some guys don't use their call sign.
Yeah.
A lot of them tend to hide their locations. They don't put it on their house. They'll move it into a park or a shopping centre or something that's nearby to where they live.
Yeah. Paranoid.
And where are we?
But you are informing SondeHub of where the balloons are, and SondeHub is giving you information about
Oh, you've got one. Yeah, okay.
which ones are in the air and where should you be listening. So it's a two-way communication with SondeHub.
We've got a question, if you could just repeat it from Zoom. So what happens if we want to track a club balloon from 10?
You can't with
Can't.
these. That's a different software altogether.
It's a different format of telemetry,
Mm.
and you can't. I am sure there will be a firmware out there that does it, but I'm not aware.
They do
of
it on the Raspberry Pi. There's a version of the ARIG guys have written a version
the
for
problem.
and also what Mark was doing before. Where are we now? Where should I go? If you click on Melbourne Airport, you can look at historical. You can see all the previous launches, and you click on historical and ask you what month do you want. So you can go on there and choose a month, and then generate historical ones. So the 5th month there, that'll just fetch those. Or you can get rid of that screen. Or you can do predictions. I've got to fetch that first. It won't let me kill it. I'll fetch that first. So what that's going to do is bring all those little circles up on the map where the previous ones were, and we can delete the historical, and then we can we should be able to. Don't know why it keeps bringing that up. It's got generate predictions. There we go. Now it's going off and it's looking. It knows roughly what payload the weight is, what the gas that's put into it is going to be, roughly what the weather conditions are going to be, wind conditions and all that sort of thing. So it's predicting. You go for number 1. This is tonight. This one here, number 1. That's where it thinks it's going to go. So Peter will be up tomorrow. There's another 2 there he can pick up. 1 and 2. That'll be tonight, tomorrow. Tomorrow night's over here. It's going to go up around the back of Gembrook, roughly. And then you go, they're right up to, I think it's about 7 days. 6 or 7 days of predictions. Sometimes they're way out, and other times they're pretty good. The predictions are pretty clever software.
It's amazing. The balloons sometimes follow absolutely crazy trajectories. They go like this.
In about
what are you thinking? And they do. Well, it understands the wind direction is quite different at different
Yeah.
levels.
In about 15 minutes, they'll do the evening launch, and you'll start to see activity on the screen. But we'll probably having tea and coffee by then. So,
Yeah.
yeah.
Typically, what height would they go?
26 kilometres, probably up to 30.
30.
24 to 30 kilometres. That's when they burst and they start coming down. When they come down, they're only coming down at about between 4 and 6 metres a second when they get low. But at the top, when they're up in light air, they're coming down at about 28 metres a second or something like that, really quickly. But once they come down, they don't have parachutes. Most of them. Only the ozone one has a parachute, as far as I understand. I haven't got one of those
Yeah,
yet.
burst balloon flapping around is enough.
But they have the
drag.
they have the radar reflector. I should have bought one tonight. The radar reflector and the parachute, and that slows everything down, and it comes down. It'll hit you on the head and frighten the living daylights out of you, but won't damage you.
There's a lot of people who are very interested in this. There are forums and Discord channels and all the usual stuff. WhatsApp, yeah. So there's a lot of people do this stuff.
So this is where you can turn something on the chase mapper. I've turned chase on here, so that means when I log on and if I'm away from home, it'll come up with a little car on the screen automatically. And that one, if I go out looking, that one, it's gone now. It was over there.
Yours.
Here. I'd normally just hook that up to the antenna in the car, the mobile whip in the car. Just hook it up, and it'll just bring up the Latin long. So when I get really close, I can put the Latin long into a map, into Google Earth or whatever. If I've got the internet, you can get an offline map, but also use another thing called maps.me, which is all offline maps. And I can put the Latin long in there, and it'll just say this way or this way. But normally I would just use, because I'm into radio direction finding, I don't worry about that. I'll get the location, write it down, but then I'll just get a receiver and an antenna and go off and DF it in the bush. It's much more fun for me doing that than just knowing exactly where it is and just walk up to it.
Whatever turns you on.
Yeah, that's right. Oh, well, it's good fun, yeah.
Mm.
That's what I'm into. Anyway.
No,
And if you're looking at the tracking stuff, when an actual one goes up, another screen will come up and it'll have all the information beside it. And the Raspberry Pi units will measure the signal strength in dB.
Yep.
And the TTGO will measure them in dBm. So it'll be minus dBm, and then the others will be like 10, 20 dB.
And they're completely different.
Okay, I think that concludes this evening. Thanks everyone for your attendance and for the Zoom team putting up with the vagaries of technology. I think the image quality wasn't its best, but hopefully the editing of John will see us with an improved version online in the coming days. Thanks to Mark, greatly appreciated, giving up your time and educating us on the nuances of radiosondes and your progression through this facet of radio.